Now we go into a new domain, which is integration of fractions by breaking a fraction into further partial fractions. Okay, breaking a fraction into further partial fractions. Now, how do we do that in terms of theory? If supposing I have 1 by, let's take an example, 1 by x minus 3 into x minus 8, supposing. Okay, I can write this in terms of two partial fractions. This is a composite fraction. I write it in terms of two partial fractions. Now my aim is to find out the value of a and b. Now how will I do that? I take the LCM. Okay, so hence I'll get a into x minus 8 plus b into x minus 3. Now I compare this first expression with this expression. Now obviously the denominators are the same, so the numerators also have to be the same. So 1 has to be equal to a into x minus 8 plus b into x minus 3. The numerators have to be the same, so this has to be equal to this. This equation has to hold for all x. This is an identity, so this equation has to be equal to this for any x, for all x. Am I clear? So this will hold for x is equal to 3 also, x is equal to 8 also. Right? So if it is holding for x is equal to 3 and x is equal to 8, I put x is equal to 8, this will give me 5b, and hence I'll get b is equal to 1 by 5. Similarly, x is equal to 3, I'll get 1 is equal to minus 5a plus 0, or a is equal to minus 1 by 5. Hence, this expression can be written as minus 1 by 5 into x minus 3 plus 1 by 5 into x minus 8. Right? Okay? This was only one of the ways in which we can find out the value of a and b. You can also do it in another way, which is as follows. Find out the coefficient of x and find out the constant coefficient. Now, compare coefficients. On the LHS, do I have any x component? I don't have any x component. So the x coefficient has to be equal to 0, or a plus b has to be equal to 0. And the constant coefficient minus 3a, sorry, minus 8a, this will be, right? Minus 8a minus 3b is equal to 1. Okay? Minus 8a minus 3b is equal to 1. So I'll get two equations in two unknowns. I solve for the values of a and b. You will ultimately get the same thing. ठीक है? ये दो तरीके हैं to find out the values of a and b. And this process is called partial fractions. So there are multiple ways. This is the simplest partial fraction. There may be complicated partial fractions also like this. X minus 2 whole square multiplied by x minus 3. Supposing I get this as a partial fraction. Now what are the possible LCMs of this? What are the possible multiples for this? So the possible multiples for this will be x minus 2. Another multiple possible is x minus 2 whole square. Another possible multiple will be x minus 3. Okay? So these are the possible multiples. So for this particular fraction, it can be broken up into three partial fractions with x minus 2 as one of the multiple for this LCM, or one of the factors for this LCM, x minus 2 whole square, another, and x minus 3 independently will be another. So these are the three possibilities These are the three factors which are possible for this LCM. Now you solve it in the usual way that I have already taught you, by comparing coefficients or by putting in the values. Okay? So this will be other partial fraction method. There is another possibility. I may have x square plus 3 into x plus 5. Right? So I may have an x square plus 3 multiple here in the denominator. So if I need to find out how the partial fraction for this will look, the numerator will be ax plus b instead of only a now. Because if I have a quadratic equation, I may potentially have the remainder as ax plus b. I may have an x component in the numerator as well. Here, this is a linear expression. For a linear expression, if I have an x, in the top, I will obviously have a remainder out of that. Like for example, if I have x plus 5 by x minus 2, this can be easily written as x minus 2 plus 7 by x minus 2. So 1 plus 7 by x minus 2. So if the numerator and the denominator have the same degree of x, then obviously I will be able to find out some quotient plus a remainder divided by divisor. Here I have x square, that is the degree is 2. So the numerator will have a degree 1. If I would have had a degree 3 here, then the numerator would have had a degree 2. If this would have been x cubed, then I would have written ax square plus bx plus c here. Okay. Since I have an x square here, this will be ax plus b. Okay. And c is the other constant for the other partial fraction, which is x plus 5. Okay. Now, fortunately for us, till now, we have only got the simple partial fraction problem. We have never got this. But it's good to know. What if it comes in the future? Okay. Expect the best, prepare for the worst. Simple. Right? So, you should know this. If you know it, you'll feel more, confident with the topic. That's all. So, solving these two will also be very simple. Do it by comparing coefficients or by putting in the values. Putting in the values actually works the best, according to me. Okay. Chalo, so now let's do a few problems on